Hello everyone. Today's class about special diode types about PN diode, like switch diode, Zener diode, LED diode, Scotchy diode, tunnel diode, photodiode, and varactor. These are special types of the diodes. So when you start in switching diode, this is a normal single PN junction diode which is specially designed for switching purposes. This diode can be switched to states of high and low resistance clearly, which can be used alternately. So physically, switching diode it looks like this one, as ordinary but very small in size. So the junction capacitance of this diode is made very low so as to minimize other effects. The switching speed is made quite high. When the diode has high resistance, it works as an open switch and it acts as closed switch during low resistance. So this transition occurs at a faster rate in switching diode than in any ordinary one. So for switching purpose, for fast recovering type, we can use a switching diode. So where they apply this switching diode? So main application we can use a switching diode, like use it in high-speed rectifying circuits, used for ring modulators in communication, also radio frequency receivers. We can using reverse polarity protectors for both general purpose and high-speed switching application. We can use switching diode. Let's see the next special type of diode is a Zener diode. Zener diode, the symbol is looks like this one. During mostly worked in the reverse bias. That side is as a cathode side, but this side is anode side. But the operating or the functionality of a Zener is during reverse direction. The Zener is a PN junction diode that is designed to operate in the reverse breakdown region. Two things happen when the reverse breakdown voltage is reached. The diode current increases drastically. The reverse voltage across the diode remains relatively constant. So during reverse time, the current becomes increasing, but the voltage in the diode is constant. So in other words, the voltage across the diode operates in this region is relatively constant over a range of reverse current and nearly equal to its Zener voltage VZ rating. So when you see the characteristics of a Zener diode, that as you remember, diode characteristics, but diode characteristics in the reverse, it's open circuit. When the reverse voltage is exceeded through the diode becomes damaged. That you learn in the diode characteristics. But in the Zener diode is vice. The Zener diode is when reached exceeded voltage, the Zener becomes conduct, the current becomes increasing. So the VI characteristics of Zener diode are common for any diode when operated in forward bias. During forward, it's working like ordinary diode or general type of diodes. When reaching the need voltage, that example 0.7, the current becomes linearly increasing. But the reverse bias operation of the inner diode make it very important to consider. Let us look at this graph. Look at this graph. When the voltage is reached, reverse breaking voltage or VZ, we can call it a VZ. During that, the voltage is constant and the current becomes increasing. So the point where the paint is shown in the reverse bias operation, the Zener breakdown voltage, that is, after which the diode allows high reverse current through it, this Zener voltage is indicated by VZ. This incredible quality of Zener diode made it the most reliable one and have got many applications we can use. So The Zener is we can apply as a reverse bias region. So let's see ideal Zener diode and practical Zener diode. Have you looking this diagram, the Zener without an impedance or a resistance, it has perfect conductor, constant voltage also. In the forward again, perfect conduction. This is ideal. So the ideal model in Chirac curve of Zener diode in reverse breaking down the constant voltage drop equal to the nominal Zener voltage. But in practical type of Zener diode, it has an impedance or resistance. So practical model in Chirac curve of Zener diode where the Zener impedance is included. A change in Zener current produce small change in Zener voltage. So that the current is increasingly drastically. It looks like that. So this is ideal Zener diode. This is practical Zener diode characteristics. So let's analyze Zener diode. The Zener is a diode operated in a reverse bias as a Zener voltage when Vi greater than or equal to Vz, the Zener is on. It becomes conducted. Voltage across the Zener is equal to the same is or equal to Vz. Zener current Iz, that means IR minus of IRL, that is load resistance, that we get current of Zener diode. So that becomes the Zener power becomes Vz times Iz. When Vi less than Vz, the Zener becomes off. That means open circuit. The Zener acts as an open circuit. So if R is too large, Rs resistance, supply resistance, the Zener diode cannot conduct because the available amount of current is less than the minimum current rating of IZK. The minimum current is given by I minimum IR minus of IZK. The maximum value of resistance becomes resistance of load maximum equal to Vz over I current minimum, I load minimum. If R is too small, the Zener current exceeds the maximum current rating Iz maximum. The maximum current for the circuit is given by I load maximum becomes VL over RL. That the same is VZ R load minimum. So the minimum value of resistance is RL minimum equal R VZ over VI minus VZ. So this equation we can use it, the load resistance load minimum. That current becomes maximum in the IZ. Let's see example 1. In this circuit, we have a variable DC source, voltage source from 20 up to 40 maximum. And also we have a resistance source 1K, that is 1000 ohm. Our VZ becomes 10 volt. The question, what is the minimum and maximum of Zener current? Iz minimum becomes Vs minimum minus of Vz over Rs. This becomes 20 minus of Vz 10 over 1000. The result becomes 10 minus 10, 20 minus 10, 10 over 10, 10 milliampere. So during this series circuit, IZ minimum becomes 10 milliampere. What about IZ maximum? IZ maximum, V source maximum minus of VZ over RS. The same as above, V source maximum is 40 volt, VZ is 10, RZ 1000. This becomes 30 over 1000. Our IZ maximum 30 milliampere. So by this equation, we can get from this circuit I minimum and I maximum. Let's do another example. Let's see another example where it looks like this circuit. Our source 5 volt up to 18 volt. This is our input source. Our RS 300 ohm, and again our VZ 10 volt, and RL 1200 ohm or 1.2 kilo ohm. So determine V out. That means at what time VZ becomes closed. So let's see one by one. If Vs equal to V 5 volt, determine V out. Now V out becomes, that is voltage divider RL over RS plus RL after Vs. So our RL 1200 over 300 plus 100 multiplied our Vs start by 5. This becomes 500 times 5. 3 by 3, 1, again by 3, 4. So our V out becomes 4 volt. So during this time, again the VZ cannot be closed or cannot be operated. So let's again try if Vs is equal to 12 volt. What about V out? Then again V out, if 12 volt, we can replace RL over RS. Vs, this one becomes over 5 12 by 35 by 34. 4 times 12, the result becomes V out becomes 9.6 volt. Still our V out 9.6. When you multiply for 12 over divides 5, the result became 9.6. So still 9.6 in the V out, the Zener diode cannot be breakdown. Still not breakdown. To break, our V outs must be equal to with VZ. That's it. So let's to be break down breakdown mode. Let not let V out equal to 10 volt. So V out equal to RL over RS plus RL VS. So V out is 10, then 1000, sorry, 1200. RL is 1200 ohm or 1.2 K. RS plus RS 1500 Vs. Then 10 becomes 12 over 15 of Vs. Let's crisscross. So 150 is equal to 12 of Vs. So by 12 by 12. So our Vs becomes 12.5 volt. So that means when our V source is 12.5 volt, our V out becomes 10 volt. So during this time our VZ becomes conducted. So our Vs is reached during this RS resistor, and R resistor must have 12.5 Vs to be breakdown mode our VZ. Now let's continue. If Vs greater or equal to 12.5 volt, so what is Iz? Determine current of Iz. Determine current of Iz. So to determine Iz must have we get Is and must have we get IL. So Is becomes um, let's first IL. IL becomes our V, our voltage in RRS 10 volt. That's the same with our VZ. So VZ over RL, that means 10 over 1200. This result becomes IL becomes 8.3 milliampere. What about I source? I source V source minus Vz over Rs. Our result maximum voltage is 18, 10 over 300. This becomes 8 over 300. Our result 26.6 milliampere. Now Iz becomes Is minus of IL. because IS is the total current. So IS means IZ plus IL. So to determine IS minus IL. So 26.6 milliampere minus of 8.3 milliampere. This becomes 18.3 milliampere, the maximum of IZ. So by this method, we can get IZ, okay, you can get IL, you can get L. So the breaking down mode, when V out 10 volt, our VS becomes our VS becomes 12.5. So if you get VS, that is a breakdown of Zener diode. So determine IZ. To determine IZ, first you get IL. IL becomes VZ over RL 8.3. Again, determine total current V maximum input over VZ minus VZ over RS 18 minus 10 over 700, that becomes 26. This is the total current. So determine IZ, IS minus IL 26 minus 12. So the total current of Zener diode is 18.3 milliampere. So by this means, we can calculate I maximum, I minimum, and also break down Zener diode we can get by this equation. So where they apply Zener diode, the diode has main applications such as it's mostly used as voltage regulator and also provide fixed reference voltage in transistor biasing circuit, and also for peak clipping or limiting in wave shaping circuit, and also as a surge protector in many circuits, and so meter protection against damage from accidental application. So mostly used as a regulator and as a protector. That is the purpose of Zener diode or the application of Zener diode.